Alright, so now we're going to take this one step further. After simplifying, now we're going to start solving with the addition property. So we're going to learn solving one step at a time, and then we'll put all the steps together in section 2.5. So going back to the bookstore scenario from section 2.1, if the bookstore receives 30 books for a course, how can they figure out what the class limit was? So it's kind of working backwards. So before we just had C plus 5 and we could make up whatever number we wanted for C. Now we have an equals sign equals 30. The equals sign makes it what we call an equation. And so if we knew we had to add 5 to the class limit to get the number of books, now that we have the number of books, we're going to do the opposite of that and subtract 5. And we can know that the class limit was 25. And I'll explain why I'm writing minus 5 twice here in just a minute. But we can work backwards now and figure out that the class limit must have been 25 because 25 plus 5 is how we got 30. So now we're going to talk about working backwards to figure out what that missing term is. Remember, a variable is an unknown value. Well, now we're going to try to figure out what that unknown value is. So what does it mean to be equal? We think of an equal sign as what we call a balancing point. And the book does a very good job explaining this. The two sides look different, but they are equivalent or balanced. So equivalent is the equal sign, or balanced. Like I said, the book has a very good explanation of this. If the way I explain it's not making sense, go back in the book under section 2.3, and it does a very good job explaining this. A student suggested this visual, and I think it's a good way to think about it. We know that 4 quarters equals $1. 4 quarters, right, the actual money, looks very different than a dollar bill, but we know that they are equivalent. So we can use an equal sign to show that the value of 4 quarters equals the value of $1. So this is to show that the sides are going to look different, but that they are the same. If I took away one of the quarters, it would no longer be equal. So we'll talk about that, but think that both sides mean the same thing or equal the same thing at all times. If we take something away from one side, we have to take it away from the other. If we add something to one side, we have to add it to the other, so they will always be equivalent. So I thought that was a good visual, and again, the book also does a nice job of explaining that. So the goal for solving, the whole point, the whole reason we're doing this is to figure out what x is equivalent to, or whatever letter. What is it equivalent to? Your final answer should look like x equals some number, or some number equals x. We prefer the first way, like x equals 7, but if you end up with 7 equals x, you didn't do anything wrong, you're still done. That's what your answer will look like. Alright, so we're going to very carefully solve for the variable. We have x minus 3 equals 5. We're going to do the opposite operation to get x by itself. So right now it's minus 3. One thing I tell students that have trouble with this is to find the equal sign, and if it helps, make it really bold with a different color. Find that equal sign. Red is probably not a good color. A highlighter would probably be good. To find the equal sign. Find the equal sign. That helps your eyes focus in and keep everything balanced. So if x minus 3 equals 5, I'm going to do the opposite operation. So opposite operation. So instead of subtracting 3, we're going to add 3 to both sides of the equal sign. So I write it twice, and I write it directly below where I'm going to do the adding or subtracting. So the minus 3 and the plus 3 cancel. The equal sign stays exactly where it is. The only thing left on the left is x, and 5 plus 3 is 8. So a lot going on there. One step is to add 3 to both sides. We add it to the left to cancel it out. We add it to the right to keep it balanced. Then you have x equals 8, which means we're done because we have x equals a number. On the next one, -5 equals x plus 2. So what we're going to do is subtract 2 from both sides. Keep that equal sign where it is. The -2 and the +2 cancel themselves out, which is why we're doing this. We want this to go away. We know that -5 minus 2 is -7. You can do keep, change there if you need to. And then the only thing left on the right is x. And that looks kind of funny, so we always rewrite it correctly, which is x equals -7. So even if the variable's on the right, we can just rewrite it once we get down to the answer, and the answer is x equals -7. So your adding and subtracting skills come in here. Here, there's the equal sign. We're trying to get y by itself, so we're going to do the opposite of +8, which is subtract 8. And we get y equals -15. If you're struggling with this, see if it's your adding and subtracting. If you need to do keep, change, you can. If the concept of what we're doing is not making sense, we can talk about it during class next week. But your answer should be the variable equals the number, and that's how you know we're done. I have a few more here to work through. If you want to pause the video and work these on your own, I would suggest that. Just try your best. And then you can play the video and see if you're correct. Sometimes it helps to emphasize the equal sign. We're trying to get r, the variable, by itself. Right now it's +13. We're going to do the opposite and subtract 13. 7 minus 13 should give you -6 equals r. That looks kind of backwards, so we're going to write r equals -6. And that is your answer. The next one, we have 12 equals z plus 19. We're going to do the opposite of plus 19 and subtract 19. Positive 12 minus 19 should give you -7 equals z. And again, that looks a little funny, so we're going to say z equals -7. I do cross my z's so that they don't look like 2's, and I cross my 7's so they don't look like 1's. So if that looks funky to you, I'm just crossing them so that they don't look like other numbers. The next one is x minus 12 equals -1. Again, it helps to emphasize the equal sign. And do the opposite operation and add 12 to both sides. So we're going to x equals -1 plus 12 is +11. X equals 11. These are called one-step equations because it takes one step to get to the answer. The bottom 3, going to add 3 to both sides here. That's m equals -9 plus 3, which is -6. Hopefully this is making sense. Here, again, if you're getting lost, find that equal sign. Some students say, well, why can't we add 5? Well, the -5 is already by itself. We don't want to move that. We want to get the letter by itself. So we're not going to add 5, we're going to add 2. We're trying to get the letter by itself. So -5 plus 2 is -3. And if it helps to cross that part out, you can, and we're going to write that the other way. T equals -3. And that would be your answer. So again, we're not going to move the number that's already by itself on the equal sign. We're going to move the number that's next to the letter because we're trying to get the letter by itself. Let's try this one more time. So again, the -7, we're not going to move that. It's already by itself. We want to move the number that's next to the variable. So 2 plus k. Right now it's a +2, so we're going to subtract 2 from both sides. We get k equals -2. 9. So make sure you understand why we're doing what we're doing, why we're moving the particular number, why are we adding, why are we subtracting, and what does the final answer mean. From here, you could plug in your answer and rework the original problem, and it should work out. So if you plug in your answer where you see the letter, it should make the statement true. That's a way to double check your work. Alright, let's take this a little bit further. Here they're asking us to combine like terms and then solve for the variable. This is again very important to find that equals sign. It's good to highlight it or darken it with something so your eyes are really drawn to where that equal sign is. We're not going to move anything across the equal sign until we clean up both sides. So here we have 2 minus 8, which is negative 6, equals k minus 2. And I rewrite the equation so I don't forget anything. All I did was put the 2 and the minus 8 together. You can use keep, change if you need to. And then from here we add 2 to both sides. Negative 6 plus 2 is negative 4 equals k. And it's cleaner to write k equals negative 4. So notice the equal sign stayed in the middle the whole time. Don't lose that. Don't move it around. Just keep it right down the center of your problem. What we're doing right now is developing good solving habits so that we don't get lost when the problems get more complicated. So we're trying to establish a very good procedure when the problems are a little easier so that when the problems get harder, we still have that good, clean procedure. So over here, notice we have a 4r and a minus 3r that we can combine. Positive 4 minus 3 is positive 1r. And then the plus 1 is still there. If it helps, you can put the 1 here. Then on the other side of the equal sign, we have a negative 8 and a positive 11, and those can be combined to positive 3. So we combined like terms on the left. We combined like terms on the right. From there, again, find that equal sign. From there, we're trying to get the 1r or the r by itself. We're trying to get this by itself. So right now it has a 1 added to it. So we're going to subtract 1 from both sides. That gives us r equals 3 minus 1 is 2. I'm not going to move the 3 because it's already by itself, and that would just screw things up. We always want something on both sides of the equal sign. And notice again, my equal sign stays right down the middle the entire time. So you keep it all lined up. You want to work these very neatly and carefully and make sure you understand each piece of what we're doing. Let's try the next one. Again, if you want to pause and try, that's fine. From here, we have negative 2 plus 2 on one side. Well, that's just 0. We leave the equal sign where it is. We have negative 4b and positive 5b, which is just b, minus 6. Our goal is to get b by itself. Here's our equal sign. Trying to get this letter b by itself. So we're going to add 6 to both sides. 0 plus 6 is 6 equals b, and a better way to write that is b equals 6. Don't freak out if you get 0 on one side. Still write 0. There's nothing wrong with 0. Some students just don't write 0 and then it just disappears. You always want something on both sides of the equal sign at all times. That's why I write plus 6 twice. On both sides of the equal sign. You want something on both sides of the equal sign at all times. If you lose your equal sign, you lose your balance. If you lose your balance, you get lost in your solving. Excuse me. Alright, one more time. Here's our equal sign. We have p minus 8. Nothing we can do there. Equals negative 10 plus 2. We can reduce that or simplify that to negative 8. Again, here's our equal sign. we're trying to get the letter P by itself. So we're going to add 8 because of the 8 on the left. We'll add 8 to both sides. Negative 8 plus 8 is 0. You did not do anything wrong. The answer is just 0. So very carefully, don't lose your equal sign. Some of my high school students, when they would get frustrated, they would draw kind of a dotted line down the middle so they wouldn't forget where the equal sign was. So if that helps, just draw that line or hold your pencil there so you always have something on both sides of the equal sign. Don't lose it. So every step of the way, keep that equal sign going down. Alright, and then the last part of this section is when you have variables on both sides of the equation. If you have variables on both sides of the equation, you can choose to move them left or right. So you can choose to move them to the right or move them to the left. Standard practice is to move them to the left. I don't always do that, and I'll explain why when we get down to the examples. Most of the time we move their variables to the left, but you can move them to the right or the left, your choice. You would then move the constants to the other side. Standard practice is to move them to the right. So if you remember some of your algebra classes, they might have said variables to the left, constants to the right. That's standard practice, but that's not always the easiest way to work it out. Anytime you move a term across the equal sign, you have to use the opposite operation, which is what we've been doing. When we move something across the equal sign, we're using the opposite operation to do so. So these 4 problems look a little bit more challenging. They have letters on both sides. We're going to move things around just like the constants. It helps to find that equal sign before you start. 2p plus 3 equals 1p plus 8. So let's see. We have 2 p's on the left and 1 p on the right. Since I like to avoid negatives, I'm going to decide to subtract the 1p from the right, and move it to the left. And if it helps to write the number 1, you can. So we have 1p on the right. We're going to subtract that to move it to the left. 2p minus 1p is just p. The plus 3 is still there, and it still equals 8. So I made that choice so that I didn't have any negatives to deal with, because we haven't really learned how to deal with negative variables. So I'm moving the 1p over to combine with the 2p, so that I'm down to just p. Because my variables are now on the left, I'm going to move my constant to the right by again doing the opposite operation. So subtract 3, because it was plus 3. So that's p equals 8 minus 3, which is 5. So this is called a two-step equation. We move the variables, and then we move the constants. You can move the constants and then the variables, it doesn't matter. It'll just depend on the problem. You just move things to the left or to the right until you're down with a variable equals a constant. That is, again, your final goal. So let's look at a couple more. We have 3w minus 1 equals 2w plus 7. So what I look at is there's 3 w's on the left and only 2 on the right. So if I have to subtract one of these, I'm going to subtract the smaller one and move it to the left so that my answer is still positive. If that doesn't make sense, I'll explain again when we get to class. So 3w minus 2w is 1w minus 1 equals, these are gone, and then just 7. So w minus 1 equals 7. At this point, the w's are on the left, so I'm going to do the opposite operation and move the 1 to the right. So 7 plus 1 is 8. So w equals 8. So when you have just one W, that means you're done and you get it down to just one number. If you want to pause and try these two, or we can work these together, it gets a little complicated here. On the next one, we have 1t on the left and 2t's on the right. So I'm going to move the 1t over to the right. So I'm going to subtract t. It's going to give me 5 equals 2t minus 1t is just 1t minus 9. So this time I chose to move the variables to the right, again to avoid a negative number. Then I'll do the opposite operation on the constants. 5 plus 9 is 14. 1t is just t. And then I can just switch that t equals 14. So you move your variables to the left or to the right, whatever will make a positive result. That's how I do it. And then the numbers will move whichever other way, the constants. Alright, so one more time with this. Here's my equal sign. You notice you have a 3 and then a parentheses with a y plus 1. That should indicate that you need to distribute that 3. So we have negative 9 plus 4y. Nothing changed over there. Don't forget your equal sign. This is going to become 3y plus 3. Whenever you notice distributing, go ahead and take care of it so you don't have to worry about it later. Go ahead and distribute so that that's done. And then look at what you have left over. We have 4y's on the left and 3y's on the right. That's a mouthful. 3y's on the right. So we're going to move the 3y's over here. Positive 4 minus 3 is positive 1y. Those are gone. Don't lose your equal sign. And then positive 3. And from there I'll move my 9. So it was negative 9. I'm going to add 9 to both sides. It's going to give me y equals 12. So I'm thinking about where to move things to avoid having a negative situation, because we haven't learned about that yet. So you move the variables to the left or to the right, whichever way will get you down to a positive 1 as a result. So we're going to continue solving, and it's going to get more complicated. This was just with the addition property. Notice all we were doing was adding or subtracting constants or variables, adding and subtracting, moving things across the equal sign to get down to a letter equals a number. And we'll take it one step further in the next section.